Hello and welcome to another video covering Python and web integration with ArubaOS switches. My name is Dick van Oeveren and in this video I will be covering a lot of things. In the last part of the previous video I performed a REST API call to an arubaos-cx switch. But it would be great if it is also possible to include the arubaos switch devices like the 2930 and 3810. So that is what I will be doing. I will build a definition that discovers the device type, the platform and software version, so that this doesn't have to be stored in the database anymore. In addition, I will add some image buttons that allow you to order the list of devices based on IP address or description. And finally, I will show you how to dynamically update page content without refreshing the whole page. In other words, I will show you how to obtain performance information from a switch every 3 seconds and update that information dynamically. Quite some stuff to do here, so let's get started. In the previous videos, I have been using an Ubuntu host to demonstrate the functionality. Now I've moved to Visual Studio. This IDE allows me to create an instance and run it on my local PC. The structure of the environment doesn't change though, and the instance will work in exactly the same way as on the Ubuntu host. Let's begin with cleaning up some stuff. In the previous video I created a table in a database that contained the OS type field in which the switch operating system is stored. So I've removed this field now. So this is the table structure now, and there was an OS type field in there, but it's not there anymore. So I removed that field. So that's what the table structure looks like now. It's pretty straightforward. The other thing is if I go to the root definition in the init file, you can see that if I do the query, so the update devices here and the insert, you can see that the OS type field is removed. So they are removed from the queries. Let's have a look at the discover definitions. I'm calling this definition in the index definition in the init file, and you can see that here. So what I'm doing here is that the information that is returned from the definition is stored in a list that contains a dictionary of the query result. So I'm doing this here and here. Okay, so the second part is there if the response is not a dictionary or when there is an error, we are setting some default values for the parameters. Okay, so if I cannot discover the device, I'm setting the type, platform name, software version to unknown. If I get information back from the definition call, I can fill that data. Let's move to the classes and to the discover model definition here. So the definition contains two parts. One part is to check whether the switch is an arubaos-cx switch, and that's here. And the second part is to check whether it is a arubaos switch device. So first I'm checking for arubaos-cx. So here's the URL that I'm providing, and with the ID. So what I can do with the URL and the ID, I call another definition here called getRestCX. The try except commands are very handy if it comes to error handling. Normally when a Python script is executed and when there is an error in the script stops further execution, and this can lead to unclosed sessions and connections, which is not a desirable situation. With the Python try except finally commands, you can overcome this. So the try command executes the line below, or the lines below, and then if there's an error, the except section is executed. There's also a finally part that always executes after the try and except. Now let me move to the get_rest-cx definition and explain what I'm doing there. So let me move up here. Okay. The first step in the get_rest-cx definition is to obtain the device information from the database. Okay, so we generate a query string based on the ID that is provided with the definition call. And then the next step is to log into the switch here. This is done by calling the login_cx definition. Let me show you that definition. We can find that one here. You can see that the definition is called with all the required parameters. It's username, password, IP address, URL, and the session ID object. The session ID object will hold the cookie value once a successful login has been performed. We can see the try except combination here. So if something goes wrong with the login, code 401 is returned. If the login is successful, HTML code 200 will be returned. So let's get back to the get_rest-cx definition, which is here. And what we do here, so after login, you can see that we are checking against the result code. So if it is 200, the login is successful, and we can go to the next step, and that is obtaining information from the switch. And we do this in this part here. We are obtaining the information from the switch with this command here. So what we're doing here is we're using the session ID.get command. We are calling with the base URL. The base URL is defined here, and we are adding another parameter, which is the URL that we have provided when we called the get_rest-cx definition. Okay, let me just quickly show you that. So that's this URL that's been defined here. So that's your definition, and we're putting that URL in the definition call there. So again, we try to obtain the information from the switch. If there's a failure, the except commands are executed. So we have a try here, and if there's no data in the response, we are returning a no data response. And then finally, in the last part, we are logging out of the switch. So we're calling the logout-cx definition. Going to the logout-cx definition. It's really simple definition here. So we do a try except combination, logging out of the switch using the cookie value from the session ID cookie jar. Now back to the discover model definition. Down here. If the get_rest-cx definition returned the JSON information from the arubaos-cx device, there should be a key value in the JSON response that has the platform name value in there. If this is not the case, the device that was queried is not an arubaos-cx switch. So if there is a key in the JSON response that has the platform name value, we can continue obtaining the firmware information. Right, so if we have platform name in the response, we are executing the subsequent commands there. So we are defining another URL called firmware, and we are repeating the get_rest_cx definition and obtaining the software info using that definition. So another check, if we have current version in software info, so if the JSON dictionary that is returned contains the current version key, we can return the full dictionary containing the OS type, arubaos-cx, the platform name, which is in the response, and the software version, which is in the software info response. If we cannot find the firmware version, we are returning a unknown version, software version. So in this part we can still return the platform name. If we cannot find the platform name information either, we are returning all types as unknown. So the OS type unknown, platform name unknown, and software version unknown. If the query switch is not an arubaos-cx switch, obviously no information is returned in the first part. So the second part is executed, which is to check whether the query device is an arubaos-switch device. Process is very similar to the arubaos-cx process, but there are some subtle differences. So let me quickly run through this one as well. One of the things with arubaos-switch is that the REST API structure is different per switch model. Although the 2930 and 3810 switches have the same structure, some of the REST API URLs are not available on one of the switches, or they return different results. So, for example, if you would query system status information from on a 3810, the information that is returned is a list containing dictionaries, because the 3810 supports backplane stacking. If you would issue the same command on a 2930, you will get different information. Now let me show you this by using Postman. Here's Postman. What I'm doing is I am querying a 2930 with this IP address is 22, and I am querying a 3810, which is this one. So obtaining the cookie information, and in the other calls I am storing that cookie information in the headers. Now let me show you. So what I'm doing here is I'm getting a system/status. So I'm using the system/status URL to obtain information from the 2930, which is cool. Now, if I execute the same URL on a 3810, I'm getting a 404 not found. So that means that this URL does not exist on the 3810. Let me give you another example by calling this URL, and you can see that I am getting a lot of good information back. You can see that there's a blades list in the dictionary that contains other dictionaries, so that contains some information there. If I do the same on the 3810, you can see that the structure that is returned is similar. However, the information is like totally different. Okay, so you can see here the all the software versions and hardware info here, but the information here is really very limited. So there are although the structure, the API structure is the same, the results that are returned are different, and sometimes the URLs that I'm calling exist on one switch, but they do not exist on other switches. This means that we have to find another way to obtain the device, platform, and software information from the arubaos-switch devices. And obviously I don't want to use different calls for each switch model. Now I have another URL that I can use to return that information, and let me show you what that API call is. It's I'm using LLDP here, and I am obtaining the local device info. What you can see here is that the information that is returned is a dictionary, and in that dictionary I have a key value pair that contains a comma separated value, and that comma separated value contains the model name and software version. So that's for the 2930. Now let me check the 3810 with the same URL and see if I can get the same information. And yes, I have the same information here. System description with the model number and the software version. So I can use this URL to obtain the relevant information from both the 2930 and 3810. Back to the Discover model here. So what I'm doing here, this is the URL that I will be using to obtain the information, and here's my try except for obtaining that information. So I'm calling the get_rest_switch definition here, and this works slightly different than the get_rest_cx definition. So let's move to that definition, get_rest_switch. It's this one here. First part is the same. So I'm performing a query and to obtain the information from the database. So I'm obtaining the username, password, and IP address. And then with that information, we're logging into the switch. And let me show you the login switch definition. And that's here. Okay, so you can see that this works slightly different. So the JSON credential information structure is different, and whereas with a CX switch the cookie value is stored in a cookie jar, with the arubaos switch devices I am generating the cookie value and return the cookie value from the login switch definition to the get_rest_switch definition. Okay, so I'm returning the cookie here. If the login is unsuccessful, I return no information. So back to the get_rest_switch definition here. So after the login definition is called, if I get a response, so if my response is not empty, I can go to the next part here. And in this section, I am performing a REST GET here, and I'm using this this URL that I have defined, which is the LLDP information. So that's sent in the call to this get_rest_switch definition. And so if there is data returned from the call, I convert it to JSON format, and I return that information to the discover model definition. And then in the finally section here, I am performing a logout. So you can see that I'm sending the headers, and so the cookie value is placed in that header. Let me just quickly show you the logout switch. Again, also a very simple definition here. So I do a try except here, and I am deleting that session here, providing the header information. So the device will know which session to kill based on the cookie information that is sent with the headers. Back to the discover model definition here. Okay, so the information that is returned from the get_rest_switch definition is a dictionary. However, the value that we need from that dictionary is a string value that has multiple values separated by commas, as we saw with when I demonstrated Postman. So it is the system underscore description value. And then what I'm doing with this Python split command, I can split this value into a list. And for this list, we need the first two values. The first value is the platform type, so the model number. And the second value is the software version running on the device. And we're doing very similar things here, returning the relevant information. If there is no information to return, we return the unknown values. Now back to the index root that called the discover model definition here. Now in the next command checks whether the returned information is a dictionary and whether the returned information does not contain the message key. If there is an error returned, the returning result can contain a message key value pair. If that's the case, something went wrong and we should append different values to the list that we're building. So if a dictionary is returned, we can append the information in the result list. That's what we're doing here. And so this information contains all the information from the database, so the IP address, description, username, and encrypted password, and the information that has been obtained from the discover model definition. So that's the platform, so the OS type, the platform name, and the software version. Again, so I said we are cycling through the complete list of IDs, of switches that we're obtaining from the database. So once the dictionary is built, we can pass this information to the index.html in the render template command here. Let's check out the index.html because I have made some changes here as well. So let's move to the for next loop that shows the information in the browser and start with the edit section. So here's where I start the for next loop, and here's my edit Jinja block. Okay. You can see that if you compare with the previous video, I have removed the select field, the OS type select field. It's not there anymore because it's now covered by the discover model definition. So instead of the select field, I can now show the OS type, which I'm doing here. And I have added some other columns, so two more columns that contain the platform name and software version information. You can also see that I have added some tags. So that's the small tag you can see there. It's basically a sizing tag that is used by Bootstrap to display smaller fonts on the page. And finally, you can also see that I am sizing the buttons to extra small dimensions. Now let's see how this all looks like in the browser. So what I can do is I can start the instance here in Visual Studio, and I actually have started the instance, so you can see that it's running here. And let me show you the browser. So that's here. And what you can see here is that you can see that the operating system, platform, and software version are displayed, which is pretty cool. You can also see that I can now order the list based on IP address or description. So I've got some selection buttons here. Now let me let me order based on IP address. So you can see that the IP address list is not in sequence at the moment. So let me just click on that one and see what happens. So you can see now is I got a ordered list now, and all the values are retrieved from the devices. Let me show you how I do this. It's really very simple. So if I check the index.html first, you can see that I have added the image form objects here, and the names of these image form objects are action, and the values of these objects are order by IP address and order by description. This means that if I submit the form, so if I click the either of the images, the action value is also submitted. And what I can do is, in the root definition on index, what I'm doing is I can do a if statement here. So if my action value is order by IP address, or if my action value is order by description, I just issue a different SQL query. So I order by IP address, ascending, or I order by description, ascending. Now for the final part of this video, dynamic updates of specific fields on a web page. This is a really cool feature. Let me show you how this works on the web page first. You can see that I have the status field here, and that status field changes every 3 seconds. So it's updated every 3 seconds. Let me demonstrate that to you by rebooting one of the switches. So I'm gonna reboot the 3810. Okay, continue. And what you can see is that the status should change to unknown in this situation. I mean, I can give it different values, but the status is unknown. And that what you will see is that after a while, when the switch is up and running, it comes back online again. Now let's go through the code. The dynamic updates function is based on a jQuery class called setInterval. This means that we have to include some JavaScript, and we do this in the index.html. I do it here. So in this script I have created a Jinja script block, and in this block I can build some JavaScript. In this example I am including a JavaScript file called classes.js. This file is located in the static folder, and that's what the URL for parameter is used. Also in the index.html file you see the super block here, and that's in the script block. Now what does that super block do? This block ensures that the script block is included in the base.html file, which I am using here. So the base.html is referred to as a parent page, and that's the bootstrap base.html. So the child pages are referred to as super blocks, and they will be included in the parent page. The reason for doing this is that if I would not use the super block, the JavaScript would be loaded at the end of the page. So it would not be, you would not be able to call that JavaScript. So if I include the JavaScript in the Bootstrap base, it will be loaded with the Bootstrap and with the other JavaScript, so with the jQuery, and that makes the JavaScript that I am defining here callable from the index.html. We will have a look at the JavaScript later on. Let me first explain what's more in the index.html. So what we have here is a little bit further in the script. There are a couple of ginger blocks here. So part of the dynamic updates is to create a list of all the IDs that are displayed on the page. And this list is used to query the devices and obtain the relevant information. So the first ginger block is to define the list, similar to a Python command. And in the second block here, ginger block, I am performing a for next loop, going through the device list that is provided by the render template command in the Flask root definition. The result dictionary is coming from the root definition, and we are extracting the ID, which is the ID that comes from the database, and we append that ID to, so we append each value to that device list object. After closing the for next ginger block, you see a div here. That's the monitor data div. And what we're doing here is we are assigning the device list object to that div object. In the JavaScript, we can obtain the information from this div, which you will see later on if I explain the JavaScript. Further down the script on the column locations, let me just go there. You can see another div, here. And this div will be used to push the data that is retrieved from the switch. You can see the data-switch ID parameter here. With that data parameter in a div, you can prepend additional information that allows you to distinguish the div, which is what we will be doing here. In this case, we are assigning the switch ID value to the data switch ID parameter. Now let's check out the JavaScript. This scriptlet is assigned to the monitor data div that we have defined in the index.html. In this function, we are creating a variable called refresh, and which is another function that is called further down the script. The function starts by obtaining the device list here. So that's the device list from the monitor data div by using the document.getElementById command. Once the list is retrieved, we can issue a for next loop and to iterate through the list. We are doing the following in this loop, and that's this part here. We are calling the monitor get data script, and the information that is returned from the script is loaded onto the data switch ID div with the relevant ID that is related to the switch that has been queried. We are setting the time interval for, so we're calling the set interval function here, and we are setting the time interval querying the devices to 3 seconds, and then call the refresh function. Now what is this monitor get data script? Well, this is something that we have to define in Flask as root definition because the script is actually launching another HTML page. Let me show you this in the init script, and that's this part here. There are quite some things happening here. Again, because we are dealing with different types of network operating systems, we have to obtain information in a different way. The process, though, is very similar to the one that I've described earlier in this video for obtaining switch information. It's basically log in, obtain information, and log out. So first we are calling the getRest definition. That's what we're doing here with a specific URL. And this is the get rest definition for CX switches. You can see the URL that we're calling, which obtains the resource utilization of the device in a list that contains dictionaries. If a list is returned, this is checked with the isInstance command. We can go through the for next loop that comes next. Okay, that's what we're doing here. Now with arubaos-cx switches, there are multiple subsystems that each have their own CPU utilization values. So what we're doing in this call is we obtain all the CPU values and we average them out in the for next loops here. If all turns out great, we assign the CPU value to the response variable. And that's what we're doing here. If the getRestCX result is not a list, there is something wrong with the query. For example, it might be an arubaos switch device that we're querying. So there is a else statement here. And so that starts the query process for an arubaos switch device. In this section we are querying the CPU values of the selected switch. Now, as I have explained earlier when I did the Postman demo, some arubaos switches devices do not support the REST URL that we're using here. However, they do return a dictionary, and on the dictionary we can decide whether we execute the following commands. If the message key exists in the response, this means that the query did not return the CPU value. In this case, we are just returning the online value. If there is a CPU value returned, we can assign that value to the response variable. Now in this root definition, we don't have to render any pages. So because we are just returning a value to a calling script. So the calling script, which is the JavaScript, will then push the information to the relevant div field on the index page. So, and that's what we're doing here. So the information that is returned here is loaded onto the data switch ID div with the relevant value. Let's have another quick look at the page just to see whether the page is refreshed. So you can see that the CPU is changing here of this 8320. So that's working. This concludes this episode of Configuring Flask working with arubaos campus switches. Be on the watch for more videos, and as always, if you like the video, click on the like button, and feedback and suggestions are welcome as always. My name is Dick van Oeveren. Thanks for watching and bye for now.